Thank you for joining me and everybody else this afternoon. You can see I had to have the appropriate attire, right, to get into this. Okay. Now, before I get I will be projecting and talking about things, and we will do some hands-on. But before we get into a quick overview of the history of the Chinese abacus, I'm going to give you a really brief history of really my encounter and my motivation, what got me thinking about doing a talk. I'm so old that if I started to say 20 years ago, that's still recent history. Somewhere in the neighborhood of 20 years ago, I purchased this book, okay, The Abacus by Jesse Dilson, which, by the way, as I've been searching the internet for odds and ends, a lot of people refer to this as a good book to learn from. Okay, so I thought, oh, good, I had bought a new one, and it came shrink wrapped with this cute abacus. And I had bought it because I thought, you know, I always wanted to know how to use an abacus, and there's the book, and there's the abacus, and that was great. And I read the book, and I learned how to do things, and then I think I put it away for 20 years, which meant I didn't remember how to do that anymore. And then sometime in the last year, couldn't tell you what month, what day, but I can visualize the moment. I'm walking through Myers. We all know what kind of Myers I'm talking about, right? Okay, go through. And I've got my cart. I'm almost ready for the checkout. I go past a big cart. Then in the corner of my eye, and I have very good peripheral vision, by the way, I see a sign that says 20% or 70% off, not 20%, 70. That gets my attention every time, okay? All right. And it was meant to be, let me show you what I found and that I purchased at Myers in Grand Rapids. Whoa is right. Okay. How could I not get this? And you won't believe the stir that I created as I pushed the cart to the checkout. And the checkout girl's going, whoa, that's so cool, right? So whoever the purchasing agent was for Myers, that I don't know how many they stocked, and I don't know why somebody else didn't get it before me. I was meant to have this, right? Okay, so. And it reminds me, have you ever seen the first Crocodile Dundee movie? You know the scene where he says, and I can't do an Australian accent or I would, that's not a knife, this is a knife. That's not an abacus, this is an abacus. Okay, there we go. However, it's not real practical to sit there with one hand and try to use it. But I will lean it right here for your viewing pleasure if you're in the front row. All right? Okay, so that's why I had that muted. You can see I took it outside of my deck with me. And so as we go through. All right, so again, yes, I'm Nancy Forrest. I am a novice abacist. And you're using an abacus today, so I guess you also are abacists, right? And I'll leave it up to you to decide if you are a novice one or feel you are an expert. I do not declare myself to be an expert. Now, for a brief history of the Chinese abacus as we lead up to it. Before numbers were invented, doesn't it seem weird to think of numbers as an invention? Okay, but right, we describe it in that way. Various counting devices were used because it was important. If you know, how are they going to indicate how many sheep are out in the pasture, etc.? Okay, and a lot of times with a one-to-one correspondence. And the literature will even come out and say how, you know, fingers and toes. Now, if you had more than 20 sheep, you might be in trouble. Right, or whatever. But marks and sand, pebbles, counting, and then leading the counting boards. And with the counting boards, that could be made out of clay, stone, wood, metal, depending on where you lived, how wealthy you were, etc. Then, instead of just drawing on the ground, for instance, they could paint or mark lines or grooves, sometimes just a painted line, other times a groove, and move anything from stones to metal discs to beads, all depending on what area of the world you lived in and how much money you had. And the wonderful part about that is that it was portable, right? It would have that. And I just put in the comment there, it's portable, but you're in trouble if you have a hole in your pocket. So, I mean, there's limits to what you could do, but in the marketplaces, et cetera, for commerce, okay, they needed things. And early on, if you were to look into the history of abacuses, that's one plural. Another plural for abacus is abaci. Double checked yesterday with pronunciation, and that C has kind of an S sound in that. The early counting boards often are also referred to as an abacus, but they didn't necessarily have the beads as we picture an abacus right now. So when you read about it, they can talk about, well, there's an abacus a couple thousand years ago. Well, it really was a counting board, not what we picture as the abacus. And so since this talk will be using Chinese abacus, 2-5 for that. And the one that you have, there's a section with 2 beads and then 5 beads below it. Okay, so that's the 2-5 bead one for the Chinese abacus. Well, it appeared around 1200 AD in China. They believe it originated, actually came from the Babylonians, but there's not hard evidence and record of where it all came from. Okay, but as far as arriving in China and really picking up as in popularity of use, widely spread. Okay, there's about a year when that happened in the form of 2 beads with 5 beads. Okay, what we would now certainly call a Chinese abacus, and about 1600-ish. Again, there's not hard and firm times about this. A modified form of the Chinese abacus where there was only 1 bead up in what we'll end up calling heaven beads, up on the top 5, began to be used in Japan via Korea. So the information went Koreans and then to the Japanese. And then in what I think, considering the length of history, relatively recently, 1930. Now, even I don't remember back personally to 1930, okay, but compared to talking thousands of years, okay, the Japanese soroban, where there's just 1 bead up on top and then 4 below. And from what I was able to read about, they are still used in Japan and in China and some other countries. They still use them a lot, including, say, shopkeepers, because they're incredibly efficient with adding and subtracting. In a lot of commerce, that's what you're doing, is adding and subtracting. Okay? All right. So just kind of following that modification, because during those years, the Chinese abacus stayed as it was. I mean, efficiently being used that way. And a little timeline, give an idea here. So way back, make use of that, it does not show up so well. When they start to talk about a hand abacus over here, it's more like a counting board, really. It's not a Chinese abacus. And around 1600, the shodi is actually a Russian abacus. And from my reading, it implied that it is used very widely through Russia, again, for adding and subtracting, including shopkeepers. They said you could walk into a store to buy computer software, and the person you're paying the money to may be doing work on the Russian abacus. Okay, so it's still depending on things that way. All right, and the word abacus has its origins from Latin, but actually the Latin from that has its origin from Greek, which probably comes through the Hebrew word, okay, originally sand. So from sand, because they were using tables with sand on them as they go through, but that's what they believe as far as the history of that goes. And the websites I have on there, a lot of information kept repeating which one had the information from a particular slide, but or there's give them credit for what I've got here. All right, so the layout of the Chinese abacus. You can see I took it to where I'm working on my new garden. I had to have this maple tree taken down. It was a big maple tree too, because that's a big abacus sitting on it, right? This spring. Okay, so in the meantime, I gave me a certain part of the yard that needs my attention. Okay, but it looks pretty, don't you think? I knew you'd say yes, thank you. Okay. All right. Now there's a crossbar, refer to that, okay, which separates the heaven beads, makes sense that they're the two on top, okay, and the earth beads. So that they also do talk about them, about, you know, the top deck and the bottom deck, but normally heaven and the earth beads. Commonly there are 9 columns. I believe that's true of the ones where we've got a classroom set that you're looking at. Often, it is possible to get an abacus that has more columns than that. It depends on what you would be doing, okay? Rather than have a really long one, though, they can set one right next to the other, which is maybe more practical in working with that. There's also, I don't remember the person's name, but somebody has a popular abacus in some areas where at the bottom is a Chinese abacus, and then they mount the Japanese abacus on top, so that if they have to do more complicated things, they've got everything they need right there, okay? And again, here we go with the Chinese abacus. Now, how to start? For instance, this book about abacus said, lay it flat, you know, or you look it up, lay it flat and clear it. However, instead of just laying it flat and clearing it, what is the more efficient way is to actually stand it up. So to clear it is to start up so it's like all zero, right? So if you just stand it up, we let gravity do the work to make the earth beads go down there, and then you lay it down and run your hand across between the crossbar and the heaven bead so they all go to the top. Now I tried it with the ones that are black, and those plastic beads tend to stick a little bit. My fingers were getting sore. I was trying to get very expert, okay? So, and yet my little one here, the beads are nice and light, so it doesn't hurt if I'm trying to do that. So a quick way to be able to clear them as we go through. So we want them all away from the crossbar, because as we want to record numbers or work with them, we bring them to the crossbar. So right now, all those other beads are there in reserve for us to make use of them when we need them. So what I hope to get to today, we'll look at addition, subtraction, multiplication. If there's time, looking at taking a cube root, to be honest with you, that's not what they were designed for. It is not efficient. I had to get my directions from a cube root from this book, okay, that was loaned to me by Professor Dersch. And part of it, the directions were a little tricky, but at least it had cube root part, because my other book didn't. And maybe the directions are tricky because it's printed in Hong Kong, and it doesn't give a copyright or any date. And it said it was translated for English-speaking Filipinos to learn how to use the Chinese abacus. I am not making this up. Okay. Okay. So, but it at least had steps in it as to how to do the cube root. And it also mentions in there how certainly today, I'm not at all pretending to be an expert, but people who are experts get really, really fast. They memorize a lot of shortcuts, because when we use the abacus, what I think is a plus for it is it helps us record numbers, but your brain still has to work. It's not like just pushing buttons. You still have to know your arithmetic and the numbers that you're using, okay? But for the really speedy ones, then they know the shortcuts, and they have competitions and special schools and all these things that you can go to. All right. So as we start out here with addition, 238 plus 617, the first thing you would do is enter the top number over on the right, okay? So what you need to know is that in the earth beads below the crossbar, each bead counts as 1. Up in the heaven beads, each one of those is 5. So in the first column on the right, here's the ones place, okay? And tens, hundreds, etc. So I'm not bringing in any decimals right now. You could make the adjustment pretty easily, okay? So therefore, to get an 8, you'd bring down 1 heaven bead and bring up 3 earth beads. Now, if you want to know the appropriate way to move the beads, there's different accepted ways. This book claims it is proven. By whom, I want to know. This is the one with no other. It is proven that if you use your thumb to bring up the earth beads, your index finger to bring down earth beads, when you have to do that sometimes, and then your middle finger to bring down the heaven beads, that is the fastest possible way. And when I read that, I was trying to do this, and I'm like, yeah, right. Okay. However, when your hand's on an abacus, it's really not that bad. But more typically, it's just using your thumb and your index finger. Your thumb to work with the earth beads and your index finger for the heaven bead. We're not actually going for speed right now, right? So I put in, here we are then with 238. Any question about why that looks like, do you agree it's 238? No problem, okay. So then what we're going to do is add in the ones place to 7. Now in order to do that, note that, and I say right down that we add 7 to the ones place, but if you're going to add, try to add 7 to that, you're going to have all the beads in the middle, right? Okay. So instead of doing that, if you can't add in those numbers and still keep, I hadn't brought this part up yet, if you're only adding and subtracting, 1 earth bead always stays down, 1 heaven bead stays up. You don't need them for adding and subtracting. Then another way to be able to actually add the 7 is to add 10 and then take 3 away. You have to compensate with it, okay? All right, so by adding 7 to that column, bring one of the earth beads up, okay, to do that. And because then we had 10 more there. So when you work with that, add 10 there. And then since you didn't want to add really 10, you only want to add 7, you take the extra 3 away from the ones place. And it takes a little practice. I will tell you that since I was doing addition and then also subtraction, my brain is like, oh no, which direction am I going now? Okay, I mean, because they're so similar, okay, as we go through with that. Now, then we would move over to, it's time to add 1 to the first column, to the second column as we would go through. And if what you've got is on your abacus, you had what you had previously. Let me actually back up here for a second to this one. In order for us to add 1, that would make this be 5. See, so you don't ever, if you're adding or subtracting, have to bring that up. Instead of that, we bring these 4 earth beads down and then bring 1 heaven bead down to stand for the 5. So that's the adjustment to kind of get used to. And then adding 6 in the third column, so in the hundred spot is not such a big deal. How many beads are you going to have to move? 2, sure. 1 heaven and 1 earth bead to the middle. Okay. And then we get 800, right? There's our 5 and 3 for the 8, 55. And you can see it's a little awkward at first, and then as we practice. So they can get to where they do it in the blink of an eye. I mean, they can beat somebody using a calculator, but not on the first try. I couldn't. I am not going to try to earn my living as an abacist, okay? That would be right after me being a singer in the top 10 charts or something. Not much chance of that. All right, here's what I'd like you to do. Try that one out. Okay? So clear your abacus. Remember, stand it up, lay it down, get those heaven beads up. You're doing great for your first try because we only expect a little bead here, bead there. And when you're an expert, all you hear is click, 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 click. We won't get there today. I'm not there. You're looking at what? If you're going to add you're going to add 5 to the 9 that you already have?
Oh, that's what.
And you can't.
Okay,
So instead of adding 5, I know sometimes it's hard to get our brain and not think the way we normally would, say, borrow or something. So if you can't really add 5 because it already is pretty populated, then think of it this way. Add 10 to the next column, and then figure out a way to subtract 5 from the first one to make up for it. Because if you add 10 and subtract 5, you've accomplished the same thing.
It's going to be. No. Wait a minute.
There you go.
No. Okay.
It's a little tricky.
So I'm adding 10 to the first.
And in case people want to double check, that's the same problem. I'm just actually putting the answer there because we don't have you have paper and a pencil out. Is there a hand up back there? No? Okay. Oh, high-fiving each other. Okay, cool. How's it going? Any brave soul want to demonstrate this? We're just one big Abacus family. Do we have a brave soul? How about this? Do I have a volunteer to come and lay their abacus on the overhead? Thank you, Alejandro.
So 2, 4, 39.
So what? How about would it be possible to stand to the side? Because see, then they're going to be able to see. Okay, so he's going to illustrate where you can see it happening.
39.
We're going to automatically put 10 here.
All right.
5 away from
Yeah.
So 2, 4, 39.
Mm-hmm.
And then we add.
You got to add 5.
Okay, so 5. This is the way I did it. I put 5, and then I said, well, those 2 make up a 1, and so I added the 1 here later.
Good. Now, which is perfect to think about because those 5 make a 10, which is a 1 in the column to the left, which is in the tens place. Now, once you get past being an abacist, they would skip the 1 step, but it doesn't matter right now. In other words, he brought down the other heaven bead, saw 2 of them, so he brought them back up, brought 1 up in the next column.
So let me show you again. How was that before? It was
2, 4, 3, 9 is you would, okay.
I need to add 5. So
Yeah.
I put 5 here, but now I realize those are 2, So I move those back up, but then I compensate by adding a 1 here.
Good. And what an abacus would do that does the same, which is perfectly correct, is when you see that, oh, I'm going to have a 10. So, or if I can't add the 5, I'll add 10 and subtract 5 away. You get to the same steps. There's just an economy of motion. Okay, now it says add 1.
So this is what I did. I added 1, and then I realized, oh, that's 5. So I move him back down and put another 1 here.
Good job. Okay? And then adding 0, don't have to change it. And then 7 in the last.
So down 1 and 2 up, and that's it.
Okay, and there's our 9, 4, 5, 4. Thank you very much. Good job. Excellent. Yes. Okay. And you can see that as somebody, like if you had to do 100 addition problems, let's picture you're in first grade and you're in Abacus addition class. That the more you do that, it's just going to get easier and easier. Excellent. And then you were explaining the logic behind it, because if you know your decimal places, etc. Wonderful. Thank you. All right, now we'll do subtraction. Okay, it's not a big leap to go from subtraction to addition if you're doing shortcuts. So when I was trying to learn shortcuts, whoa, when you're not thinking through every step in the shortcut, you got to make sure you don't go the wrong direction with it. So for subtraction, with the first number being 521, just as with addition, put in the first number. So there's, are you in agreement? Does that look like 521? Yep. Okay. And by the way, you can see my high tech. I laid an abacus on a piece of white cardboard on my floor, and my cats would do flybys. And so, but then I would retake the picture and put the beads back, start over, right? All right. So we have our first number in. And then I need to talk about, what do you think to subtract? You can't subtract 2 from 1, right? If we're looking to take 2 beads away from 1. Well, then what you can do is, any suggestions? After you, okay, there you go, perfectly, yeah. So if you subtract 10, that's subtracting 2. Remember, a bead, an earth bead in the second column is really a 10. So if you subtract 10, then you, in this case, we're actually supposed to subtract 2, correct? Well, if you subtract 10, how many do you add to make up for it? 8 of them? Excellent. Okay. So you would bring 1 bead in the second column down. That's subtracting 10. But you didn't want to subtract 10. You only want to subtract 2. So you make up for it for adding 8 more. Okay? So instead of 1, so this bead came down. That's why there's only 1 bead now in the second column. And then 3 of these go up, and a 5 goes down, and so that would be the next step. So far, and when somebody's practiced up, right, it's just a matter of getting used to it. But it definitely has a little different feel, because it isn't just a carry. You have to, how am I going to compensate for that in an economy of motions? That's part of it, is if they want to be fast. If they're using this for commerce, right, they want to use the least amount of time that they can and get their correct answer. And of course, that was the heart of using an abacus with the commerce. I didn't talk to them. I'm assuming. Obviously, you know I'm using assumptions in that. All right. There we go. And then in the next step, so now we've subtracted to 2, we'd move on to subtracting 6 then from the second column. Do we have 6 to subtract from? No, we don't have. Matter of fact, we just have a 1 there. So what do you think we could do? If we could subtract 1 from the third column, which is like subtracting 10 from here, right? I mean, always 1 over. Then how many would you add back in? 4. Okay, now we have to deal with, how are you going to subtract 1 from this column? It's a 5. Push the 5 back and bring 4. There you go. And then you've subtracted 1. Okay. And then when you, what did we say we're going to add back in? 4? But you'd see, oh, if I add 4, that's going to be a 5. I'm not even going to bother to bring those up. I'll just bring that one down and bring down a heaven bead. Now, for this one, the little one on the upper left-hand side was, that's the same picture that was on the previous slide. So to make the transition on this particular one, I knew that I wanted us to see. So there's no change in the little one, but this is then what happened with subtracting that 6. Okay? Now, the last step, is subtracting 3 going to be hard? No, because in the third column, well, there's 4 earth beads. So to subtract 3 from that is simply bringing those down. So, I don't know, for me, this was a little bit of a challenge. I didn't expect like adding and subtracting to be that hard, but to get used to it, but it's a fun challenge, right?
It's fun, I just don't.
Which I think is one reason why one of my sisters has always told me that there's support groups for people like me. My idea of fun is not the same as her idea of fun. Go figure, right? All right. So, there you go. Give it a try. Notice I made it a little bit bigger problem. But I was kind to you in the first column. And now, I'll do that so you can see if your numbers line up. Oh, there you go. Good job.
Oh, that was too cool. I like that.
Wasn't hard. You can find any shirt you want on Cafe Press. And they weren't adding or subtracting because you can see there are times where they've got like 2 heaven beads down, or else they just made the shirt not carrying. But this would not be an example of adding or subtracting, because if you add or subtract, for an economy of movements, 1 earth bead and 1 heaven bead are always at the extreme. But it has other uses. Matter of fact, the Chinese Abacus, this one book recommends, is a good way for somebody working with binary numbers. You just use the heaven beads. Okay, so that's kind of neat. Do we have a volunteer to illustrate this one? It's okay. I mean, if we do we have a volunteer to put their abacus on there and let the rest of the abacus family tell them what to do? And they'll just move the beads? How about it? Thank you. Okay, because okay, so go ahead and then you'll just clear it again. I know you, and I was a witness. She had the right answer. Okay, so go ahead and clear it. And then they will guide you. And then you want to stand to this side so I don't blind you. There we go. Good deal. Okay. All right, Abacus family. What should she do first? 643. Oh, put in 643.
Put in, okay. 6.
Yep.
Okay. Now, subtract 1 earth bead from column 1. Okay, now that was my gift to you. Okay, now what's a short way to subtract a 9? The shortest way? Yeah, subtract, okay, 10 from the hundreds, and then add 1 more bead. Now, whoops. Oh, remember, she's just found. So you mean she would add a 1 here, but if she does that, she'll have a 5. So what should she do? Yes, and then bring her. Okay. And then subtracting 2, what are you going to do?
Exchange your heaven bead for your 5 earth beads.
Oh, so bring the heaven bead, bring the third column, the heaven bead goes up? And if you take two of those away, how many earth beads should you keep up there? Oh, so bring up 3 earth beads. And of course, we're doing this, as I say, I was a witness to her, and she had the correct answer, and you do right now. Thank you for guiding her to the correct answer. Thank you. Perfect. It's a little different feel when people are describing things compared to when you're moving your beads on your own. I totally get that. All right. Well, since I know math talks can be a little dry, now is when I have to work in an abacus joke, right? Are you ready? As ready as you'll be, I get it. Okay. So an abacus and a slide rule and a calculator walk into a bar. And the bartender takes one look at the abacus, turns to the slide rule and says, "Your buddy looks really stressed out." And he says, "Yeah, a lot of people are counting on them." Okay. It's all right. You get one more joke and a poem, but not yet. The poem I just wrote this morning, I had to write it down so I wouldn't forget. I'm sorry. You know my motto is math is cheap entertainment. Okay, no matter what country it originates in. All right. Now, let's take a look at multiplication. Okay? And there's nothing special about the numbers I picked for the prompt, right? I just wrote numbers down and used examples, so there's nothing special there. And one thing I would like to bring up now, I guess a little historical note, think back to when paper was so precious, inexpensive, where it was out of the reach of the ordinary person. I mean, so that if you could work it out in a different way, which is why, you know, there would be chalk, et cetera, but, you know, paper wasn't easy to come by. Our advantage here is talk about sustainability. The abacus is the ultimate, right, as we go through it. All right. You start out, and as this is saying, on the left side of the abacus, far left, you enter one of the numbers, we know that it doesn't matter because of the commutative property of multiplication, which number, is your first number there. So 34 is showing up on the far left. And then leave a column where all the earth beads are down and the heaven beads are up to separate it from the next number, and then I put in 21. That's just to record what numbers you have, right? Because you aren't necessarily working with any, paper or something right now. Okay. All right. So we have it set up to get going. If you were going to do a long problem, much longer problem, you would either need an abacus with more columns or a second abacus next to it, because you can keep lining them up, okay, and consider that you're just going more and more decimal places. All right. So once I went through the steps, it occurred to me what this does is you still have to do the multiplication in your head. And then on the right, you're just recording the multiplication, the same kind of numbers you would get that if you were doing longhand multiplication and you put them in rows and then you add them together. So on the right, we add these together as we get them on the abacus. So your head does the multiplication, and then you guide the abacus to do the addition part for you. So we'll start out, and 4 by 1 or 1 by 4. I just happen to have typed it by, it doesn't matter there. And that means 4 units, so see how there's 4 in the first column, okay? And then I'm going to multiply the 3 up there by the 1, just like we would. I mean, the order that we would go if we were doing this by hand and had paper. And of course, 1 times 3 is 3, but we put it in the second column because it's really like you're going 1 times 30. Okay, so that, right? So you have to, in your mind, keep track of what it is, but you really just are moving over 1 column, so it's not that hard to do that. And so it's like it's a 30. We've used up the 1. So in the next step, I didn't change the number really, but since we used a 1 from the 21, the book recommended you bring the 1 down to help keep track of where you are in the problem, because you're not recording the individual steps. You can't go back and see your paper trail, okay? So the 1 that would have been up here has been brought down. It's time to move over, and now we're really going to distribute the 2, right, is what we do. So 2 times 4, we know that's 8, but that 2 is really like a 20, right? So instead of 8, it's like 80, which means then what you're going to do is add it in the next column, right, as you go through. Okay. And I'm going to be in the same position. One thing to look at pictures and another thing to be working with it on the abacus as we work with it. That is the same previous number, isn't it? Mm-hmm. Good, okay. So at this point, when we go to add in the 12, since we can see them then one above the other here, and we do it 1 column over, okay, then, not the 12, sorry, the 8. Get back in the groove here. So we actually do it in the second column, but I can't add 8 to the second column. So instead of adding 8, we'll add 10 to the column to the left and subtract 2 to make up for it. So those 2 come down, and that's why there's only 1 here, and then 1 of these earth beads went up. Okay? And then the last thing to take care of will be to take the 2 and multiply it by the 6. Oh, what am I making? I'm making those numbers up. Thank you. Okay. Yes, no, that's right. So when we go 2 times 3, we will get the 6, right? I believe that's going to be on the next slide. But we would, that's actually like 20 times 30, which means it's like 600. So it will go in the third column over, All right? And adding 6, remember there was just one bead there, so adding 6 to that is not a big deal at that last step. And we end up with 714. So the trickiest part, and once you do a 1 or 2, it's not that bad, is keeping track of which column am I putting it in. And notice how the progression, it kind of was one column over until we used them up. That wasn't so bad, was it? Okay, then let's try one.
It works too, multiplies bigger numbers to put over here.
Right. So if you have big numbers, see, you would need another abacus next to it, or else it's going to run into your information. Yes. So remember, clear your abacus, record the numbers over on the side, and I will, whoops, I'm sorry, that one I don't want to show. That one I actually do have some steps following it instead of just giving the answer. So I better hold up a little bit here while you give it a try. Yes. That is true. So I honestly I didn't learn a mathematical operation that needs a second heavenly bead. But I know that they exist because I didn't investigate everything that you do. Because you also really don't need the bottom earth bead, which is why the Japanese abacus has 1 bead and then 4. So if you're going to be doing addition and subtraction, multiplication then as well, because and the division thing is like repeated subtraction, because multiplication is repeated addition, you don't need those beads. But there are other things they could be used for. Binary numbers, again, for the for the heavenly beads, but not for adding and subtracting, multiplying and dividing. Okay? I didn't need them for a cube root either. But as I say, there are other things that I haven't investigated why they did use it. I didn't get that far. I wondered the same thing, but I didn't dig in far enough yet to find out when they use those. Right now, they're kind of for looks. Kind of for looks. Plus, like for Alejandro, he used it to reason through. Do you know what I mean? You can reason and picture it, yeah. By the way, those who are done, the answer is 4,088. If you want to check your work. And while for those who are done, I want to mention to you that I was told by my office partner, Professor Lee, that children in the countries that use this, they do special finger exercises. Mr. Lee, would you mind demonstrating? I don't actually remember which one. They would practice doing that and do it very fast, so it helped them with speed on the abacus. Push up, bring down. Strengthening those muscles too. But I'm sure as far as the speed of going, okay. Let's run through. Then some other people are saying I got it. So there's 56 and 73 are put in. Whoops. And I didn't take the time to put all the words in because there'd be a lot of steps there. But in multiplying the 3 times the 6 and getting 18, and then 3 times 5 would give 15, but it really would be 150. So we'd add in, 5 to the second column and the 1 to the third column. If I've got, well, maybe how many steps behind am I here? Okay, and then, whoops. Actually, it helps if I push that in the right direction. That is the end, okay. Until finally it would look like this. At the end, if you'd like to go through it more slowly, I'd be glad to at the very end, but right now, a couple more things to see. Okay.
Nancy, I have a question.
Yes,
So
that one is a different problem. You're right, that's the first problem. Yes. Sorry, Monica.
Are
The-
they thinking 3 times 6, or are they thinking 3 times 1 earth bead and then 3 times 1 heaven bead?
I don't know how they think. That is actually a really good question.
Because when I started doing it, I was thinking 3 of the earth beads, 3 of the heaven beads.
It is
and exchanging them.
Conceptually, it would have a different feel. And you're picturing a heaven bead is carrying the value of 5,
Right.
and yet your brain is managing it in a different way. Interesting. Okay, for me, after all of decades of thinking one way to, switch another way, I wasn't falling into that. But actually,
That's the first thing that I thought of was,
oh, I like
3 times
that.
this guy and then 3 times that guy.
Yeah, very neat. Yeah. That was the one where it ends, as I say, with some steps we can show. But I want to make sure we've got about 8 minutes left. I would like to show you this video. There's a lot of great math videos on that website from Harvard at Math in the Movies. Okay, some wonderful clips from various movies. First of all, he did have a contest with an abacus, and by the way, it took place in Brazil. Okay, and he was in a restaurant or whatever, and the abacus beat him hands down with addition. Beat him by a little bit in multiplication. When they did a division problem, it was a tie. He won with the cube root. They don't lend themselves to doing cube roots easily, and he did kind of luck out with a number. When you read, because it's actually described in this book, they didn't take into account some parentheses, so it wasn't multiply by 12, and then multiply by 4, and then divide by 3. Okay, there was some simplifying, but it didn't matter. Whoever was writing the script didn't realize this is actually the formula that he was using, and he did that in his head. Okay, and his numbers were correct. I disagree with him when he says somebody using an abacus doesn't know their arithmetic. They sure do. Did you feel like you had to use arithmetic today? Okay, so they sure do know that. But here's a case where something like a cube root, hands down, doing it in a different way would be easier. Just to give you an idea here. Yes, that was one. That was Flip doing one flyby. I described that to somebody, and they said, well, you should tell them this is so easy, even a cat can do it. No, he is not trying to put numbers into the abacus. But we won't go through every step, but it's really applying an algorithm. And I haven't gotten it to work yet with a 1729.03 because the directions are a little bit tough through the different translations, okay? But I finally got it to take the cube root of 1228. And there's these steps here that you have to go through with it. You need a second abacus in that it would be what's called a root number, a square number, and whatever you're trying to take the cube root of, the cube root number goes there. So just to give an idea with this, and let me go on. So I've got the number, the 1728 at this point is all that's in there. So then you make your root number be 1. You subtract 1 from what's called the first period of the cube number. So they're grouped in 3s, and that's why the 1,000 is now missing. okay, the one bead that was in the fourth column, and then you make your square be a 1. Normally you would do add 1 to the root number, add that sum to the square, add 2 to the root number, add that sum to the square, subtract that square from the cube number, and you keep going on and on until the square number is smaller than what was in the set of 3. Well, as soon as we subtracted 1, the period to the left is a 0. So then you go into a different thing that you do, and you start making the root number be 10 times bigger than it was, and you do more additions, and this is it in fast forward because we're pretty much out of time. But I will at least show here, once it all subtracted out, you don't quite have your answer yet. But the fact that it all subtracted out perfectly meant that it was a perfect cube. So then you still add 2 to the root number, and then divide it by 3, and then you have your cube root. I think it's kind of like doing some of those worksheet forms when you do your taxes. You don't know why they say to do this and add it, you just do it, okay? And when I finally got it to work, which is why I was a little upset with the cat, when I would be halfway through and the beads got knocked around, it got to start over. Right? Okay, so it actually gave me an appreciation of how much arithmetic they do have to know. It's a combination of the skill, the efficiency, and running the numbers, okay, having a very good number sense as they work with that. So it's 4:01. Thank you for sharing this time with me. Okay. Thanks.